Hello everyone and welcome to this video about microservices architecture. In this presentation, we'll try to explain what is microservices architecture and to deep dive a little bit in microservice world. So let's start with an introduction. In this introduction, we're going to introduce the microservice architecture and try to compare between microservice and other kind of architecture. So let's start with the introduction. The main question that we need to answer is what are microservices? And in my point of view, microservices are autonomous and independently deployable services that are small. So how small microservices should be? They should be small enough to export or to implement the one business capability. The only one business capability should be implemented or exported by a microservice. Imagine that we have a system with different business capability, like e-commerce website, for example. In this e-commerce website, there are business capability for managing the catalog or creating or managing the PIM, the product integration management, or managing a basket, or managing uh, the shipping and the payment. So all this capability will be developed or implemented in different microservices. So uh, all those microservices or the small piece of code or that are autonomous and independently deployable should collaborate or have to collaborate between each other to create my website platform, my e-commerce platform, or to create my application. So you just keep in mind that microservices are services that implement only one business capability, that are autonomous, independently deployable, and collaborate between each other to create an application. So why we need microservices to build a project, to build a platform? So just start with the monolith. What we use in our application to build our project. The monolith is mean that we have a single process with a single host, single database, and it's consistent technology. What does mean that all the projects will be built in the single bundle of the application and it will run in the single process. And maybe all the application will be deployed in a single host. And even if we need to scale the application, the whole bundle will be deployed in another server. So we cannot distinguish between different parts of the application. We cannot deploy a part of an application in one host, another part in the application, other host. So the whole system will be deployed and run in the same host. It uses a single database means that your application will use the single database that contain all the data model for the different parts of your system, and usually it's consistent technology that you start building your system using some kind or some version of the project of technology. We use the same technology and the same version of technology for your whole system. What I'm saying here that doesn't mean that Monolith project is wrong or is a mistake. Monolith project is something that is very simple to handle because we have one code base that can maintain your code base very easy because you just to clone your code base and start debugging your code base and you can improve your code base with the time. The deployment is something also is very easy because you have one application to replace. You have only one package to replace if you want to upgrade your project. So monoliths are not wrong. We still build or we still create some very good projects with monolith technology. So, saying that, why do you really need microservices? So, with the monolith, the problem starts coming when your application, your project goes at scale. Imagine that you have a project or website. This website, for example, is an e-commerce website. It's a small application with monolith architecture. Things are going to work very well. But once where the number of the developer involved in your project goes up, you start your project with 5 developers, now you have 50 developers working on your project. You have many users, many profile in your application. We have customers, we have B2B user, B2C user, we have some kind of webmaster who is managing your website or marketing teams are also working in the same website to improve your product. For example, you start handling a large amount of data because you are managing a lot of brand in your e-commerce website, and maybe you're collecting large amounts of data for your marketing team. So saying all that, that means that your system become very difficult to maintain because you are facing big data problem. We have a lot of developers working on the same code base, and they have to maintain the same code base. They work with the same code base, and everything is connected as is entangled models. So the marketing model with the product model with the catalog model, everything is connected. And when we make a change in any of these model, maybe you can impact another model. So m- monolith system, when it goes at scale, when the project when the teams grows, when the project starts to have a lot of models, so this the dependency will grow at the same time, and we can create some technical debt because we start building the project using some kind of technology. This technology maybe has become deprecated, and we need to change the technology. And if you want to change the technology, something is very expensive that need to change a large part of the system. You can take an example if you use some open source framework and this framework become deprecated or not maintained anymore. So we need to change this technology into system, something that can gonna cost you a lot and maybe that creates some impact in your day-to-day business. So monolith system start to have some problem or when it become very risky to deploy, when we cannot go to production as quick as you want because before going to the production, you need to have some manual tests, some automated tests. You should test all the whole application before going to the production environment. And maybe your deployment requires downtime. Maybe you need to deploy at midnight because you're going to stop the system to stop your website. And maybe if you are managing a worldwide application, midnight at the US, for example, is a midday at Asia or another part of the world. So monolith system become very difficult to scale, and usually the horizontal scaling is not efficient because we have to copy all the system. You have to install all the monolith in another instance to ensure the performance that we need. Let's have an example of the Black Friday when your website is facing a problem of performance, for example, and you want to increase or to scale the order model with the search model, for example. We cannot have this features to scale only a part of the system. You have to scale the whole system. Something has become very, very expensive. Another problem for the monolith when it goes at scale is it's reduce the agility of your system because you reduce you increase your time to market. You increase the effort that you have to make. We want to bring a new idea to the market or to fix an issue or to develop or to deploy a new feature of your platform. So uh, another thing that I want to pinpoint here is I call the distributed monolith. One of the solutions that comes to mind when we have a tangled model. So to try to separate between the different model in different services, but to still use this shared database. So here we are not decoupling our system. We're creating the tight coupling in the database. We are writing this dependency in the database of the system. And when we make a change in your model, for example, you have to redeploy all the service on the application. So in my opinion, it is the worst case scenario that the center should to avoid to use a shared database between different systems because we are not resolving the problem of the monolith. We are just adding the burden to deploy all the services at the same time. So, how can microservice help us to improve the agility and to improve also the time to market of our services? So, microservices has a lot of benefits, and between them, there's a small services that can be owned by a team. Only one team will be responsible of your microservice to maintain your microservices, to build new feature, to fix issues in your microservices. And something that's very easy to understand because you are just focusing in one business capability, and the number of lines of the code is not very huge. So everyone in the team can read the code, understand the code. If they can improve the code, they can rewritten the code. So you can written the code because you want to improve your business capability, and you can written your code because you want to use another technology instead of developing with Java or Python. You want to switch to Golang or to another programming language. So the choice of the programming language will be adapted to the business capability. Depending of your business capability, you will choose your technology. Let's have an example. If, for example, you have a catalog and a basket in your website. So in the catalog, you need some search, very complex search. You can use Elasticsearch as a data store to store your product. But in the meantime, in the basket, you don't need to store your data to persist your data. You can use a memory database like Redis, for example, to store your basket or your cart. Uh, and also for the technology, we need to standardize where it makes sense. We will see that in the coming chapters when we need to standardize. Standardize, it doesn't mean to use the same technology or the services, but to use the same template to standardize, for example, the output of the log, to standardize the way we are exposing the status of the microservice. Another point is related to individual deployment. So your deployment is low risk. It's low risky because you are deploying just a small part of your system, or you are impacting just a small part of system, and you are minimizing your downtime. What it means that you can have a frequent update a day. You can update twice a day. You can update many times a day. The scalability is very cost effective because we're going just to scale. We're going just to scale your one microservices. If I come back to my example of a Black Friday, we're just going to scale order microservice because we know it's facing a performance problem. We can also automate the scalability of our microservices depending of the metrics, of some metrics. The agility of the system is also improved because we can adapt rapidly to the market. For example, we can bring a new idea to the production environment uh, very quickly because we need only to change a small part of our code. And agility also comes with the easy to reuse because we are creating exposing the business capability. We are not exposing some API to manage the UI. And this business capability can be used for example, your website, but can be used by the mobile application, or also the same business capability can be used by the third party or other partners that share with you the same share the same bunch of the shared business capability. Oh, microservices doesn't come for free. There are some downside of the microservice or some challenges to the microservices. So microservices solve some problems but bring new new challenges. The challenges that come from microservices developer productivity because when using microservices usually we are using new patterns, new designs pattern are used when we want to build our microservices, and maybe we are using some brand new technology. So it needs time for the developer to 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 be trained in this this design pattern and in this technology to become more productive. The complexity of communication or interaction between microservices, as I said in the first slide, that microservices has to collaborate between each other to create a system, and this collaboration doesn't mean that they should have the chatty communication between them. So if we have two microservices that communicate a lot between each other, we know that the boundary or the border between microservices are not too well done. So this problem, we will focus on it in the coming slide. We can face challenges in the deployment and ensure for the deployment that we need automated process for the deployments. We cannot anymore afford to have manual deployment because we can have many many instances of microservices and many environments where my microservice will be deployed. Another challenge that we can face because we are managing distributed architecture is the monitoring. We should have standardized a place to check the log and to monitor all our problem for microservices. Uh, so microservices, we can succeed with microservices. There are a lot of projects running with microservice architecture, and one of them is is a, a proof of concept developed by Microsoft team is called eShop on Container. It's e-commerce platform. It's not trivial, non-trivial application. Is meant actively maintained by Microsoft team and also is to use some containerization technology and is a cross-platform and is very well documented. In this example, you can see the boundary or the border between different business capability between identity, for example, a catalog, ordering, basket, and other microservices. So each microservice has its own database. It's responsible to store its own database, and the technology of the database may differ between different microservices, and also the technology used to develop the microservice can differ between different microservices. Even the part what is important is the business capability exposed by my microservice. It's the contract of the microservices. For example, here with the catalog microservices, the business capability is going to expose you kind of to search using filters, using some kind of criteria on the shirt. This is a business capability exported by my catalog microservice. The way this business capability is developed and stored and the technology that's going to be used for this business capability, this is the responsibility of the microservices teams. So they are the only responsible to maintain and to choose the adequate technology to develop this business capability. So in this kind of architecture, the, we have the bounded context or the border between microservices. We cannot, for example, access directly from the identity microservice identity code to the catalog database or vice versa. We cannot, for example, from the basket access to the order or from the catalog access to the order, something like that. If we want to share information or data between different microservices, there are some patterns that can be used, event bus or pub-sub design pattern to publish the information and to react to those events published by other microservices. So in another side, we still have client application and a front-end application composed from by mobile application or traditional desktop application or maybe another third-party system. So between microservices and the front end, we can have kinds of a middleware or kind of API gateway. The responsibility of the API gateway, we see that in details in the coming chapter, will be to expose a single entry point to my to the front end and to route and to route sorry and to route the request from the front end to the adequate microservices. So to say microservices give us the choice, that not give us the solution to the problem, but give us the choice. They give us the choice to choose the adequate technology to resolve our problem. To give us the choice to have the adequate design to resolve our problem and to expose the business capability of microservices. Sure that you can use your favorite programming language. If, for example, you feel comfortable to use some kind of programming language or some kind of technology, we can use it to develop your microservices. I have just info out here that eShop on container is developed using .NET technology and Azure or Cloud Azure technology. So thank you for having me for this chapter and see you in the next chapter.